Okay, so like Simon yesterday, I don't have a presentation, but I'll just walk a little bit through some of the code and show like the critical parts of the layouting system that I implemented, so that hopefully you get a better idea of what the point there was, and what it can offer, what it can't offer, and maybe also like Josef said, think about how to integrate that with other tools, because it's not inherently linked to Maki in any way. It is pretty linked to observables, but I think it can work outside of that as well. Okay, so well, this window is kind of in the way. Maybe I'll just move this down a little bit. Oh, yeah. Okay, so the layouting system is kind of all built around this type of grid layout. So you can see all this stuff. Yeah. Yeah. Okay. All right. So we have this grid layout, which just has a bunch of grid content stored in a vector. So that's the first thing already. You see that the content is not stored in any grid-like fashion. It's just stored in a list, and every grid content tells itself like where it is exactly in this grid. And we can have a look at this grid content thing. So a grid content is basically just something that stores any kind of object. It doesn't matter. It stores a span, so that would be like from row 1 to 2, from column 3 to 4, something like that. The side is sometimes you want to place stuff only on a specific side of a grid cell, so you will see that later. And then a couple of nodes for updating. And a grid content also stores as parent, so that's the grid layout that it's in. And then the important part, like the important struct for the layouting itself. So what does an object need to support in order to be layoutable? So that's this this thing here, the layout nodes. And basically we have only these 6 components that you need to have. So that one thing is like the bounding box that the grid layout tells an object. So like this is what you can use. This is the place that I assigned to you. Then we have protrusions. So that is one feature that I never really saw in any other library, which causes a lot of problems with aligning plots and stuff to other things, because often you want to align the axis lines of a plot and not the actual bounding box of the plot, which would include the axis labels and stuff like that. So the protrusions are basically the things sticking out on all the 4 sides of a rectangle in a grid, and they contribute only to the gaps in the layout and not the cells itself. Okay, then we have the computed size and auto size. So that's a bit confusing maybe at first, but there's basically a difference between whether an object can calculate its own size and know that. So that would be auto size. So for example, that's needed for text in a layout, because text has a bounding box that it can compute. So it can say, well, my size is maybe 30 pixels wide and 10 pixels high. And then there's the computed size, which includes the user specified width and height settings, and can then, this is basically what the layout sees. So the layout doesn't always see whether an object, like what the actual size of the object is. This is needed because otherwise the layout, for example, would always shrink to text, even if you don't want that. Then the computed bounding box is the actual bounding box that the object ends up in. And I'll show in a second how that looks. All right, and then there's the grid content object, like the same thing that's stored in the grid layout. It's also, so there's this double link, like every layoutable knows about the grid layout that it's in, and every grid layout knows about all the grid content that it has. Okay, so let's maybe go to one of the objects, one of the layoutable objects. So this is just text, and you can ignore most of this, but so here you can actually see that how one of these layout nodes is instantiated. So we make layout nodes with the attributes width, the attributes height, the horizontal alignment and the vertical alignment. So those you always need. And then the user can, when they open, make this object, they can specify bounding box, but they don't have to, the suggested bounding box. And then basically, the only interaction that this whole text object has with the layout nodes other than this is here, that whenever any of the, like when the text changes or the text size or font, rotation, padding, then some computation is done how big the text actually is. And the auto size node of this text thing is updated. So then basically the object can say, well, I'm now 50 pixels wide and not 30 pixels wide. And on the other side, whenever this computed bounding box node of the text changes, then it just positions its text in that. I mean, the computation doesn't matter, but that's basically what happens. So the layout says, this is your spot. And then the text says, okay, now I move my content there. So that's one thing, like the layout doesn't, like the layout is basically something outside of the object. It just tells the object where to move, right? So that's basically, I tried to separate the functionality there. And I'll try to show about how that works. So here we have, like they should all be open. So let me just open a scene, a layout scene. Okay, maybe it wasn't open. Let's see. Oh, by the way, this GLFW thing, it's very useful for me because it keeps your window floating up even if you change something in the code, if you have a small screen. So I don't know if that's of any use for anybody. But okay, this will take a while now because we, oh yeah, okay. So this is like an empty scene now that we have. Just a second, yeah, an empty scene. And now we can put an object into it. And let's just make this a layoutable axis. So once we put that in there, yeah, I don't know why I didn't pre-compile this, but it will not take that much. I thought I did, but I must have done something in the meantime. So here you can see the amazing pre-compilation time. But anyway, so once, like I haven't actually done anything with this and a layout yet, right? So basically the axis will be placed in the scene at a default position, which is actually, it doesn't make any sense in terms of layouting. So for some reason it's really small. Oh yeah, so you can see it ended up down here because the layout doesn't know about this axis yet, but it was just placed into the scene. So being in a scene is different from being in a layout. So, but what we can do now is assign this axis into the layout. And at this point, there will be a link established, like it will be, the axis will be placed in a grid content object, like I showed you here. So it will be placed in one of those. Where is it? I scroll too far. Here, one of those. And then the protrusions of the objects and the computed size, those two nodes, which basically tell how big the object is, those will be connected to the grid layout and then inform it how big the object is. So once I do this, so it has to compile again. For some reason, maybe showing the video just makes the whole thing slower. All right, so now the object has been placed into this grid, and now occupies this one grid cell that we have. So what we can do now, we can, for example, place the object in a different cell. So if we just place it in cell 1 and column 2, which right now doesn't exist, the layout will actually create this new column and move the object there. So this is helpful because, as I said, there's this double link between so the object knows the grid layout that it's in, and the grid layout knows what objects it has. So once you move something like this, it can basically it doesn't cause this object to be placed twice in the layout. It's just moved. So now you can see that the grid layout was enlarged, and we have now this empty space of the same size as here, which is like the old column, and we can do the same thing, like move it to row 2 and column 2, and now we have all these empty things where there's nothing in there, and we can, for example, take them away again with with this trim command, and now it goes back. And so you see this all interactive and updating immediately because of all these observables telling each other how big an object is. All right, so we can, for example, put in another axis. So you see that ends up again down here. Now we could put that next to the other object, and now it's already like a nice a nice layout in that way. And now these objects can have all these kinds of features that you want that use either the computed size or the protrusions. So one thing, so those labels, for example, those cause protrusions to the left, and those cause protrusions to the bottom. And if I now add an axis title, for example, for the second axis, it will cause a protrusion at the top, and then the whole thing will move in order to incorporate that. So, and then still this is quite, this is flexible. So what I find annoying in like Matplotlib and the like is that it always feels quite rigid to have to place objects in these hierarchies of grids, which you can also do there, but they're kind of tied to that position, and you cannot easily move them around. And so here you can basically just take two objects and swap them, and it will now they change positions in this grid layout. So this is all very flexible, and this is also because the objects themselves are not like the drawing objects. They're all just lying in the scene at the same level. They're not like nested deeper into it or moved outside of it. The only thing that changes is where they are in this grid layout, and the grid layout in the end just tells them, here's your rectangle, move there. All right, so now we can, for example, I don't know, put like a plot into the axis, and could do another axis in the second row with 2 columns, and you see that adjusts immediately. And now, for example, you can also do stuff like this, like specifying all the rows and the last column plus 1. That will, and then we place a legend there. So this means the legend will end up in the new column over here and in both rows. So that will kind of center it. So this way you can, just a second. Oh yeah, it has to compile that again as well. Yeah, all right. So that's a legend now. Where can I move this? Maybe here. I don't know. There's not enough room on my screen. Right, like that. So again, with this, so with the legend, you can see now how this computed size and the suggested size work. So I can maybe try do legend layout nodes and then computed bounding box. So that's one thing. So this is basically where the actual, this little rectangle is. So that's one thing, but the other thing is the suggested bounding box. And the suggested bounding box is actually much larger. The suggested bounding box for this thing is the whole column, because I placed it along both rows and in this column. So you can see that the grid layout noticed that there is an object which can tell its size in this column. And so it shrinks the column to the width of this object, because the object is able to tell it, that's my width, right? So what I can actually do, for example, is I could put the width of the legend. I think I could just put that to nothing, for example. So now you can see that both the legend forgot how big it is, and the grid layout also doesn't know how big it is. So that's usually not what you would want in a layout like this, but that's how the layouting system at least works. So if we make the so what it was auto true. So that means both the legend knows how its size and it tells it to the grid layout. Another thing that you can do is the element itself can determine its auto size, but it doesn't tell the layout. So in this case, you can see that the column that it gets is exactly as big as these other 2 columns that we have here, right? So often that's what you want, because you don't want, for for example, you place the legend down here and you don't want the whole thing to shrink in width to the width of the legend. So, right, it gives you all these options, which can be confusing, I think, in the beginning, but they give you a lot of flexibility. And actually, that a lot of this was what I was always missing from other libraries that don't have this. Okay, so let's put it back to auto true. As I said, the suggested bounding box is actually quite big. And why is it in the center of this? Because the v-align attribute is right now at center. So we can, for example, put that to top, and then it will be up there, or to bottom. And I mean, you get the drift. So what we can also, like the same thing that allows us to move stuff around in the grid layout. And I said that it's not a matrix storage, but it's just a list of objects that just tell where they are. So that means you can actually place objects in the same cells of a grid layout. And that's how you would, for example, make a legend hover over an axis, right? So you can actually move the legend into the layout cell 1, which is of this axis. So I can just execute that here. So now it's inside the axis, and now it happened what I told you with the auto size. So actually now the whole column shrunk to the size of the legend, which might be what you want, but in this case it isn't. So actually we can put the width to auto false, and now the axes can be as big as they want again. And we can trim the layout because now we have this this column that we don't need. So it's like this. And then the legend itself has this other keyword, which is the margins. We can put it a bit away from the thing, so now we could, for example, put it on the left, or we could put it on the right, or we could put it at the bottom. So all this is very, very simple and very flexible. And I think you can basically do anything you want with this kind of system. Yeah, the other thing that I wanted to show, just to make that clearer, was how this thing with the protrusions works. So let me just make another scene with 3 axes, like this. So now we have 3 axes again. And now I will create a rectangle in all the protrusions of all the objects that I find. So for every object, for left, right, and top and bottom side, put a rectangle there. And as I said, things can end up in the same spaces. So right, now you can see what actually these protrusion values are for the different axes. So one thing you might see is that the red thing here is wider than the actual numbers. So that is one drawback of the system, is basically when do you actually want to recompute a layout? And I decided that I don't want to recompute a layout if I interact with an axis. So you can see that this doesn't go with it. But if I did adjust the layout now in this moment, then it would just, like, the whole thing would always have to recompute every time I interact here, right? So that would be kind of bad. But what you can always do is, let me comment this out. We can just, for every axis in the whole layout, we can do tight tick label spacing, and that will set this protrusion value to what it measures, what the text is like in size. So you see it changed. It's not perfect. That's because of a bug in the, or like an inadequacy of the backend text code. But in principle, it could be perfect. So you can see that it's a little bit different. So for example, if I now move back into this, yeah, like until the numbers get kind of small, right? So like here somewhere, and I run this again, then now it should take all the, yeah. So basically it shrinks, so that doesn't need all that size. Yeah, so I mean, there are of course tons of other things that you can do, but that's like the main gist. So I showed you how you can make an object layoutable. It's just with these layout nodes that you put in there, and it always needs to be able to get this like the vertical line, the horizontal line, and the width and the height. And then basically the layout knows what to do with it. And I mean, I can try to show you. I also showed it to Simon. I don't know how easy to understand it will be. So this is one thing. Like this shows how the grid layout is actually. Let me put this out. this shows how this updating cycle works. So if we have a grid layout, and in that grid layout there is some content, and there's another content which is also grid layout, so that's nested grid layouts, and that grid layout has content again, so maybe an axis or whatever, then both the computed size and the protrusions, when they change, so that's this observable thing, they will immediately notify the grid content that it needs to update, and that will notify its parent grid layout, which is this thing. And this will now recompute its own size and protrusions. And if they change, then it just tells all its children their new positions, and then notify its own parent again if it has one. So basically, this whole thing works in a nested way, and can be made to arbitrary depth. So I haven't found a situation yet where I couldn't realize a layout that I wanted to have with the system. Okay, I think that maybe I should stop here, because there's so much more complexity that you could see, but those are basically the simplest parts, how it works. And I think this could totally be implemented in any other system. I don't know, like the same logic with this protrusion stuff and so on could maybe also be used in something like GR. It makes a lot of things very nicely aligned easily, and you can tweak everything you want, which to me is very important, because if there are only defaults, then I usually get annoyed with them at some point and want to change them. So you can change everything. Yeah, that's it. All right. So if you have any questions, how something works or whatever, just ask.
Cool, thank you. That looks pretty amazing.
Yes, really.
Actually,
Awesome.
I have a basic question, because this looks super cool, but what I don't understand is, because I was spying your file tree in your Atom window, and it looks like you guessing from the file names you don't really need Mackie, you just add Mackie integration. So my curiosity is, could the dependency structure be flipped? So can this become a layout-based package that then outsources kind of, then must be whatever 3 primitives then the plotting package needs to implement, and then it works?
I think it definitely can. There's no, like, the only thing, it uses abstract plotting functions, it does, but those are things like bounding box, and that's basically it. I mean, of course, these objects like the color bar and the button and stuff, but those are not really important. Those are just things that are implemented to see whether the layout works, right? But the layout is separate from that. And the layout itself doesn't need any, it's basically dependency-less. The only thing that it needs is observables. And I guess it could be re-implemented without those, but I don't see why it should.
No, those I agree you should keep. But what I was curious about, maybe it can be a discussion later in the afternoon, is that there are many things that are not Mackie that need layout. For example, even Interact. There's not very good layout support in Interact. But of course, from whatever an HTML object, there must be some way that it can tell you its bounding box and whatnot. So what I was thinking, maybe we can discuss more in detail later today, is whether this can become a layouts base, and then this would allow other plotting packages to have layout, or even a long-term project that I've been playing with Simon of having widgets that do not depend on a backend. Because for composite widgets, you need layout, and we don't have a language to discuss layout so far.
Yeah, I think that can be possible. So one thing that I've been thinking about something a lot, and I haven't come to any definite conclusion, but you know, you never want to do unnecessary work, right? And of course, I felt like this was not available, like neither in MATLAB, where they tell you to like just tweak your bounding boxes until it looks right, or PyPlot, like Matplotlib, they have some experimental thing, but it's not it's not so nicely, like it doesn't, it interacts with a lot of the lower level objects, and it's kind of too deep ingrained in everything. But I was wondering, like on a web, in a web space with CSS and HTML, how close you could get to this with simple CSS specifications. Because I thought, like, can you actually do this with something like Flexbox or Grid or whatever? And
Yeah,
I
exactly.
don't think you can, because there's still this logic which tripped me up in the beginning quite a bit, where like if you have, maybe I can show that, I don't know. Like for example, if you have, let's just take this again. Oops, you have this, the scene, and you put now maybe another grid layout, a sub grid layout at maybe, let's say, the first 2 rows and also the first 2 columns or whatever. So this is just a grid layout. So if you do this, and now you put an axis in the sub grid layout at 1, 1. So like this. So now it still takes the whole thing. And it also computes the protrusions correctly. And basically these gaps, they always need to have this, they always need to take the size of the biggest object in them. And at the same time, these objects, like it's the same, this gap is the same gap for every object that has that boundary on the left side of this grid layout. Even if I put another nested thing into this, into the subgrid layout that also borders on the left. So they all share this gap basically in a way. And I don't know how you would do that with CSS. Maybe I'm just not good enough at CSS, but it's basically this nested thing where it always takes the thing that needs the most space, and that determines what's going on here. So for example, I could maybe just to show it, just to drive the point home. So you could do a sub GL2, which is then in the subgrid layout, also 1, 1, whatever. It's another layout. Like that. Oh, I didn't actually run this. And if we now put into this sub GL2 in the first columns and on the left, so this would be something like putting something in a protrusion. So I would actually put something in the space now. And if I put a rectangle there with a width of 200, then that should, if it doesn't, yeah. So you see now it made the whole thing bigger, even though they all share the space, right? So yeah, that's the basic property that makes this nice layout, and the nesting and everything that makes it possible. But it also required some logic where you actually have to traverse all these the children and find out which is the biggest object and so on. Yeah. So definitely it can be made in something like layout space. And I think it's also necessary to do it because I don't think you can do it with any other thing. But I have to think about it.
Mm-hmm.
That was a long answer, but maybe that at least showed what the reason behind actually doing this was, because you might think you can just easily do that with any kind of grid system. I don't know. Okay. Any other questions?
Do you have any plans for 3D stuff?
Can you maybe elaborate a bit on that? Because in what way would you want 3D stuff?
I mean, does it automatically work if you have 3D scenes? I know there was an issue at some point ago, but I'm not sure it was solved or not. If you have like a cube in a scene, and if you want to lay out this.
So, I mean, in principle, this is all just about rectangles, right? So I was actually trying to
have 2D layouts basically, and it doesn't matter if you have 3D or 2D objects in them.
Right. That doesn't matter at all. So this axis is like, it has a scene right here, which is orthographic projection. And you can actually put 3D plots into this as well. They will just look flat. But this could be any other projection type inside this rectangle. So one difficult question, I mean, I can just show you like the, if you just look for MATLAB 3D plot, so you can see that they use this projection, this orthographic projection, in which it's in a way clearly defined where this thing ends, right? It has the lower corner here, the upper corner here. These things are always parallel, so it kind of fits nicely inside of a rectangle container. So once you know what kind of view you have, you can kind of fit it nicely in a container. And that's exactly what they do, even though they don't go all the way with it. But that's how you can make something in 3D fit into a layout. So you would just lay it out like this. I mean, just place this as best as you can in this rectangle, and then everything else should still work. It's a bit more complex with like calculating the protrusions from the labels here, because they're not so nicely separated in dimensions like the Y and the X labels are here. So basically the X labels are completely independent from the Y, and here it depends on the rotation of the plot, so everything will move. But it's still possible to make it workable for an interactive use, and then have a command like I showed before, like this thing with tight tick level spacing. So this you could always do, that you just say, well, now shrink everything so that what I'm seeing right now fits perfectly, which I think is fine for this for me checks both boxes of it being interactive enough and it being perfect for the publication, because then you can still say, okay, now calculate all the concrete bounding boxes. So 3D should be no problem, but I was working on this axis type and I haven't gone so far yet with it. It's confusing stuff.
Okay, thanks.
All right, anything else? I tend to talk very long, so just interrupt me if you want to proceed with the next talk also. Don't know how much time I took.
Do we have something like constraints for if you do automatic changes, like the minimum margin should be 5 or whatever?
Mm-hmm.
Or do we have, for example, plans to reduce the text size if there are too many windows in your grid?
So that's a bit difficult with the constraints. So in the beginning, when I started this whole project, I started by porting some constraint solver from C++ because I thought that's what you needed. But there's a problem that I found, which was that there are many solutions to a layout that satisfy all constraints of such a constraint solver, even if the plots don't take the whole area. So in a sense, you say something like these gaps must be a certain size and they have to be equal for our plots and stuff like that. But nothing actually says use the maximum available space. And once I noticed that that's like the main constraint that I want, that everything fits into this rectangle, that there's just one analytic solution basically. So I just calculate that manually. I just say like, how many things do I have? So there are no constraints in that sense. I thought about, like, basically there's a problem once something is under a constraint and it could have a different size depending on how everything else is in the layout, then it cannot really tell the layout its size anymore without being told first how much space it needs. But it doesn't know that before it knows the size. So it's kind of this loop. So I don't think it can be implemented. I think that's, yeah, I thought about it quite a bit, and I think it's very hard to do. Okay. Yeah. But something like a text box, it could always say, like the text box itself, imagine like this rectangle was a text box and it said, give me as much space as I want. And then it notices, wow, I'm being made really small by the grid layout. Then the text box itself could decide to change its content. And then it could say like, now I'm really small, and I tell the grid layout that you can do that, but the grid layout cannot really decide this. Okay.
Oh, thank you.
Sure.